So we have to start with electrochemistry. What is electrochemistry? Electrochemistry is a branch of chemistry which is concerned with the conversion of electrical energy into chemical energy, as well as the conversion of chemical energy into electrical energy. These two opposite processes are carried out in two different kinds of cells, which are electrolytic cells and voltaic or galvanic cells. An electrolytic cell is a cell in which the process of electrolysis takes place, and in this process, electricity causes oxidation reduction reactions to take place. Whereas in voltaic or galvanic cell, the oxidation reduction reactions, they produce electricity. Now, what is meant by electrolysis? Electrolysis is the decomposition of a compound or an electrolyte into its components by the passage of electric current. What is an electrolyte? It's a substance that contains freely moving ions, and therefore it conducts electricity. For example, ionic compounds and the aqueous solutions of acids and alkalis are called electrolytes. Now we have some electrolytes which are strong and some electrolytes are weaker. So what's the difference between a strong and a weak electrolyte? Weak alkalis and weak acids are considered as weak electrolytes, whereas strong alkalis and strong acids are considered as strong electrolytes. Then what about the salt? Salt is considered as a strong electrolyte. For example, sulfuric acid, hydrochloric acid, sodium hydroxide, sodium chloride, lead bromide, these are all electrolytes. Molecular substances are non-conductors or insulators because they contain no free electrons or other charged particles because that can flow through them. Ethanol is made up of molecules. So is petrol, paraffin, sulfur, sugar, and plastic. So these covalent non-metals never conduct electricity, whether in solid or in molten forms. Now let's see what's the difference between electrolytes, an electrolyte and a conductor. Electrolytes. Electrolytes are compounds and they conduct electricity due to the freely moving ions. Electrolytes or ionic compounds do not conduct electricity in solid state, but they do conduct when melted or dissolved in water. Electrolytes decompose or they undergo a chemical change called redox reaction when they conduct electricity. Conductors, on the other hand, are elements and they conduct electricity due to the freely moving electrons. The solids that conduct electricity are the metals and graphite. These conduct electricity because of their freely moving electrons. Conductors can conduct electricity in solid or in molten states. Conductors conduct electricity without undergoing a chemical change. Now let's discuss in detail the process of electrolysis, which is breaking down by electricity. Here you can see an electrolytic cell. An electrolytic cell is an apparatus in which electrolysis is carried out. It consists of an electrolyte. Here we have the electrolyte. This one is the electrolyte. And it consists of two electrodes which are immersed in the electrolyte, and they are also connected to the battery. Graphite electrodes carry the current into and out of the into and out of the electrolyte. Now mostly graphite or platinum electrodes are selected, and they are chosen because they are unreactive and inert, and they do not react with the electrolyte or with the products of the electrolysis. Now, when the process of electrolysis happen, the electrolyte has to be kept in molten state. So it has to be heated. Heat must be supplied to keep the salt molten. Now you can see a battery. It has a positive terminal and a negative terminal. The electrode which is connected with the negative terminal of the battery gains a negative charge and it forms the cathode. The other electrode which is connected with the positive terminal of the battery is called an anode and has a positive charge on it. So when the process continues, first of all, the electrolyte, it dissociates into its respective ions, like it changes into positive ions and negative ions. The positive ions are called cations, and the cations move towards the cathode. The negative ions are called anions and they move towards the anode. Now when the current starts flowing, there are two circuits that are made. The one that consists of wire and the battery is called the external circuit, through which the electrons flow. The electrons always move from the negative terminal of the battery towards the cathode. So this is how the electrons move. And then back from the anode, the electrons move back to the from the anode, they go to the positive terminal of the battery. It forms the external circuit. Whereas in the internal circuit, it is the movement of ions. The ions move to carry the current and they form the internal circuit. Now consider that our electrolyte is molten NaCl, so it will ionize to form sodium ions and chloride ions. The sodium ions will move towards the cathode as they are positively charged and they are cations. So at cathode, the sodium ions accept electrons and the sodium begins to appear below the cathode. At the positive electrode, the chloride ions give up their electrons and the yellowish green chlorine vapor or chlorine gas can be seen at the anode. So let's see how the process occurs. For that we can write the reactions that occur at the anode and the cathode. But before that we must remember that at cathode it is always the process of reduction that takes place at the cathode, and the process of oxidation occurs at the anode. First of all, at the cathode has a negative charge, so the sodium ions would move towards the cathode to get discharged by gaining the electrons. The cathode is negatively charged and it has electrons deposited on it. Sodium ions, which are positively charged ions, they will gain those electrons and will form sodium metal. Whereas at the anode, the chloride anode has a positive charge, so the chloride ions, which are the anions, will be attracted towards the anode to get discharged by losing their electrons and will get atomic chlorine. Now these atoms of chlorine, they combine together and they form chlorine gas. So we can write the equation like this: two chloride ions will lose two electrons and a chlorine gas will be formed. We can also write the overall equation. So for that we have to balance the number of electrons. For that we can multiply this equation with 2. So we would get 2 sodium ions plus 2 electrons, and the anode equation is you can cancel the number electrons, and your final overall equation would be 2 sodium ions in molten form, 2 chloride ions. You will, as a result, the products are sodium metal and chlorine gas would be formed at anode. Now we can also see the electrolysis of other molten salts like lead bromide. Again, lead bromide will ionize to form bromide ions and lead ions. Now at cathode, what will happen? The cations, which are the lead ions, will move towards cathode and they will get discharged by gaining electrons, and you will get neutral lead over there by the process of reduction. So lead is gaining electrons and gain of electrons is reduction. So the process of reduction happens at anode. At cathode, the bromide ions will go and they lose their electrons and will change into bromine atoms. The bromine atoms will combine together to form this bromine gas, and you can see over there reddish at the anode, reddish brown gas would be formed. And as you can see at anode, bromide ions are losing electrons, and loss of electrons is oxidation. All right, so the process of oxidation occurs at anode. And then you can also write, you can balance the number of electrons, you can write the balanced overall equation for molten lead bromide. Here in the table you can see this table shows the anode and the cathode reactions, or you can say the half equations. The half equations are ionic equations showing separate oxidation and reduction steps in the redox reactions. So remember that at cathode, the reduction occurs because of the gain of electrons. Here magnesium is gaining 2 electrons to get discharged or to lose its charge. Copper is gaining 2 electrons. Aluminium has oxidation state of +3, so it will gain 2 electrons to get discharged. And at the anode, the process of oxidation takes place. Oxidation means loss of electrons. So you can see oxide ions losing electrons, bromide ions losing the electrons. And finally, you can see the products of electrolysis of molten electrolyte. We have different electrolytes like lead bromide, sodium chloride, potassium iodide, copper bromide, zinc chloride, aluminium oxide. And you can see that the metal is always formed at the cathode. Over here at the cathode you will get lead, sodium metal, potassium, copper, zinc, aluminium. So you will get metals at anode, and non-metals like on the anode you can find bromine gas, chlorine gas, iodine, bromine, chlorine and oxygen. So non-metals is metal is always formed at anode. I hope you have understood the topic. So thank you for watching. Please subscribe, like and share.